Section 4.5, Intro to Functions. Well, we're going to start this section before we get into functions by first defining what a relation is, because you have to understand that before you can really understand what a function is. So to begin, a relation is really any relationship between two things, any situation where we have an independent and a dependent variable. Okay, independent, dependent variable just means two different aspects, two different things to consider. An example I have here written is your paycheck that you get for working. Your paycheck could be one variable, the hours you worked is the other variable. So you have to think to determine which is independent, which one's dependent, which one depends on the other. Hopefully that's an obvious situation. Your paycheck will depend on how many hours you worked that week or that 2-week period. So because of that, we would say our paycheck is the dependent variable, whereas the hours we worked is the independent variable. Okay, whichever one depends on the other is the dependent variable. The amount of your paycheck depends on how many hours you worked. You can think of the independent variable as the thing that changes freely. However many hours you work, that changes all the time. One week you might work 20 hours, another week you might work 30. That changes kind of freely, whereas the other changes as a result of the independent variable changing. So now relating this to ordered pairs, we can do that. In the previous sections we were looking at graphing ordered pairs as an x and y coordinate. Well, typically in math, when we graph equations, we solve them for y first. We get them into y equals form. And then based on that, we find ordered pairs by picking a random x value and then determining if x is this value, what does y then have to be? And so what we're doing is we're changing the x value, and then the y value depends on whatever x value we picked. So for that reason, in math, we always consider our x variable, or our x coordinate, our independent variable. Whereas our y coordinate depends on what x value we pick, so we call our y value the dependent variable. And that will always be the case. You consider your x coordinate your independent variable, y value your dependent variable, because the y value depends on the x value. So that's an idea of what a relation is. You have a kind of real world example, and then anytime you have some sort of ordered pair, we call it a relation. Now functions the idea of a function is going to be any type of relation, but in which every independent x value has only one matching dependent y value. So this means you can't have repeated x values, because if you have the same x value repeat that correspond to two different y values, then this kind of definition doesn't technically hold then. You'd have an independent value that has two dependent y values. So I think if that wording sounds confusing, you just want to really remember functions as far as graphs and ordered pairs. Well, if it's a function, then the x's can't repeat. If the x's repeat each other, then it's not a function. So if you're given a set of ordered pairs, or we'll look at the bottom of the page, all the different ways they could give you a relation, you just determine if it's a function or not by seeing if the x values repeat. Now some other aspects that have to do with functions is that of domain and range. Domain is another way of pretty much saying your independent x values, your independent variable. So a domain is all possible x values in a relation, whereas your range is all possible y values in a relation. One way to remember that is D comes before R in the alphabet, domain and range, D and R. X comes before Y in the alphabet, X values, Y values. So domain, X values, range, Y values. Okay, so that's the way I always kind of memorized which one meant which X or Y value. So using that idea now, we're going to look at the 3 different ways you could be given a relation and determine what the domain and range of those relations are, and also determine if they are a function or not. So our first example is when you're given a set of ordered pairs. Usually in math we give a set a name, you know, a letter. In this case we're calling it set H. So set H in this example is the set of ordered pairs -4, 1, -2, 1, and 5, -2. Slide this up here. So looking at that, we can determine is this a relation, or sorry, is this function relation a function or not? So do any x values repeat? That's all we really need to check for. Our x values are -4, -2, and +5. Remember, every ordered pair, these are our x values, whereas the second coordinate are our y values. Well, our x's never repeat. -4, -2, 5, so we're good. This is a function. You might notice that the y values do repeat themselves, 1 and 1 here in these 2 different ordered pairs, but that's okay. That's not having 2 dependent values for one single independent. That's having 2 independent values for, 2 different independent values for 2 different dependent. So y equals 1. That's okay that it's repeated. But not because the x values are not. As long as the x values are not repeated, we're good. Now on to the second part of the question, we need to give our domain and range. So in giving our domain, all we need to do is list all the possible x values that were in this relation. So -4, -2, 5. And if it's a set of numbers, we usually write it in these braces. So -4 is the smallest, -2, and then 5 is the biggest. We usually write it in increasing order, although it doesn't technically matter what order you write the numbers in. Then our range. Well, our range is all possible y values in this relation. We have 1 listed twice and then -2 listed. So our possible y values are -2 and 1. We don't need to write the 1 twice, even though it shows up twice in our relation. It's just saying that our possible y values in this relation were the numbers -2 and the number 1. So it is a function, and there's our domain and range. So that's how you handle it if you have a set of ordered pairs. Another way that you could be given a relation is that of a mapping. When you're given a mapping like this, everything in the left set, the left kind of bubble or oval here, those are supposed to be considered your x values, your independent variable. And everything on this right bubble, this right oval, are supposed to be considered your y values. So mapping is called a mapping because technically all of the x values over on the left hand side are mapped onto the specific y values on the right. So if we look at it, we see the x value of 6 is mapped to 2 different y values. It's mapped to the value 2 and also mapped to the value 4. And because of that, that means it's not a function. We have an independent x value that doesn't only have 1 dependent y value, it has 2 dependent y values. So it's not a function because the x equals 6 is repeated. but we can still give a domain and range for this, and our domain listing all your possible x values. -3, 0, and 6. And then a range. -8, 2, and 4. So not a function, but this is the domain and range for that relation then. So we would just call this a relation. Every relation could be a function, but doesn't have to be a function. Now the last way to check, last possible format you might be given something and asked if it's a function or not, is that if you had a graph. Okay, we have a graph of a line here, we have a graph of this curve looking like a U, we call this a parabola, and we have a graph of a circle. Now when we're looking at a graph and determining if something is a function, we use what's called the vertical line test. And the vertical line test pretty much tells us that if we draw a vertical line through this graph, it cannot cross more than one point. Cannot cross more than one point. So if we were to take a look at these three different graphs, and I was to draw a vertical line, and no matter where I draw a vertical line through a angled line like I'm doing here, you see it only crosses at one point, at one point, at one point, at one point. And no vertical line will ever cross an angled line like this at more than one single point. So for that reason, it is a function. Now the reason why this vertical line test works is if you draw a vertical line, vertical lines always have the same x coordinates along that vertical line. If you remember, a vertical line has the equation x equals some number. So if you had a vertical line that hits in 2 points, that means those 2 points have the same x coordinate. So if they have the same x coordinate, that'd be like a repeating x value. So that's why it can't hit more than 1 point. Looking at our next two graphs here, even on a parabola, it's kind of hard to tell here where it's really steep, but even if you were to draw a vertical line through here, it's only going to hit 1 point. And over here where it's less steep, it's pretty obvious a vertical line is only going to hit 1 point, and another only 1 point, and another only 1 point. So with a parabola, the middle graph there, again, vertical lines, no matter what kind of vertical line you draw through it, it's only going to hit 1 point. So we also consider this a function. Last example, a circle. Okay, well this hopefully is a little bit obvious now that we've discussed the other two. A vertical line you could draw would be like this one that clearly hits more than 1 point, or even if you drew it somewhere over here, obviously this vertical line hits more than 1 point. So what this means is along this line, both of these points would have the same x coordinate, the same x value, just like both of the points on this line would have the same x value. So for that reason, a circle, an oval, shapes like that, those are not going to be functions. And we'll get more into some other domain and range specifics in the next section, still 4.5.